Alright, so we will continue our project. So we've done our analysis. So now let's look at performance when we do plastics injection molding simulation lah. So obviously, let's go over back to our part. This is our part. So everything has been designed properly. Let's check whether we are going to have any problem when we do plastics analysis. So go over to SolidWorks add-ins. You can click SolidWorks Plastics, and then this additional tab will pop out. This is SolidWorks Plastics. You can also search this SolidWorks Plastics under this Model 3 over here. This P icon. So this is available lah. So we can start by doing only shell lah. So shell is much faster that we can get the results. If you do solid, it will be going to take too much time lah. So let's go and go to shell, right click. We are going to select manual and click next. So this is the cavity chosen. This is cavity. Make sure it is cavity, not cooling channel. And then click next. Currently the default size chosen for me about 1.5. So I'm supposed to get about 21,000 number of elements. So let's try to mesh 21,000. That seems quite reasonable lah for 21,000. So I'm going to accept this one lah. So let's get a good number, 1.5 mesh. Just so that we can repeat lah. Mesh is done, click next. And then click OK. And then click OK one more time lah. So now everything has been done. Make sure your mesh is 21,000, node is 10,000 only lah. Material is ABS, so this one is okay. If you click mesh model, you're going to be able to see lah how the mesh has been created for you, including your ribs and everything. You might have a problem if you problems when you are meshing if this engraving number is too small lah. You're going to see some mesh distorted like this, right? So this kind of heavily distorted lah. It's okay for you to suppress the engraving numbers lah in order for our simulation to run easily, easier. If we were to do that, you need to mesh again lah to remove. So you can go back to your Model 3 and remove this one lah. Cut extrude. You can suppress just to make sure our mesh is much better lah, more smooth. There's no problem. So if we were to do that, you need to mesh again. Go to shell, manual again, next. Use previous meshing parameter, yes. And then click next. And then click mesh. And then click next. And then click OK. And OK one more time lah. So now it has been meshed properly. It should be easier lah to solve everything. So once you've done that, make sure you select the correct polymer lah. Currently the polymer is this one. Oh, PCABS Oh, you got to change lah. So mesh, you're done. Go to polymer, open database. And go to ABS and then, currently it's like this. Generic material of ABS. Okay lah, this one. This one is okay. You can see the polymer material data, melting temperature, maximum mold temperature 80 degrees, ejection at about 90 degrees. Okay, click OK. You don't need to set up anything lah, especially the process parameter for the injection molding, let it be. Flow injection factor, nothing. Injection location only you need to set lah. So injection location, you want to open setting, and then you can try lah, predict flow pattern or automatically add location. For example, this one, click one, it will tell you where you're supposed to do the injection. I couldn't find it. Where is it? I don't see it. If you click add location, you're gonna be able to see lah. Add location. Click this one. I don't see anything. Click X first lah. Injection location, open setting. There's nothing yet lah. So I would suggest you can study lah where is the best location. So for me, if the best location would be somewhere along here, because if you were to look at it, you want the injection to go in from this side because you need the rib. The rib will act as a channel lah to distribute the plastic material properly. So either this side or maybe this side. This is much better, I think, because of this D card. Yeah, I think this one is better lah. I can click here. Add location here. Somewhere around here. You can see the size. How can I see the size? Pointer diameter. 1. Patutlah tak nampak. So change to something bigger. I think this is the best location lah. If you can try putting other places, you see what happens lah. So add a location and then click OK. So once you're done, there is this injection location lah at this particular part. So you can of course run everything lah, flow and pack, and flow, pack and warp. So for this analysis, since I don't have too much elements, I'm going to try to run everything lah, flow, pack and warp. Right click, click run. If your computer is very slow, just run flow analysis only, okay? For the purpose of this study, I'm going to run everything lah. Hopefully it doesn't take too long. You can see the progress of the filling coming from one side. Okay, so my analysis has been done. If your analysis has been done, you will see this result lah. If you go over under the results tab, this is the results advisor. Here will be 3 types of result: flow result, pack results, and warp results. So let's go to the first one, which is flow result. We can firstly animate first how the plastic flow is going inside. What is the progress? You can see because of the rib over here, it helps to fill everything up. There's a rib bottom here, right? So it fills much faster. If you don't have the rib, it's going to have very limited way to go across. So you can study here under the results advisor. So they will tell you lah what are the important things lah. So next thing, you can go over lah. For example, this one, fill time is about 1.28 seconds. Pressure at end of fill, the result. Bulk temperature, end of fill. What else? Cooling time. You can see the cooling time is about 12 seconds. That's long. Temperature at end of cooling still very hot, 138 degrees. And then any sink marks. So these are the sink mark that is expected to be able to see lah. So that's why we want to avoid any thick cross section lah. As you can see here, I can see a very huge sink mark here because of the thick material over here. So maybe that is something you want to do about. And of course, here, this is the model that I haven't modified here. I want to show the thicker cross section is going to have big problem with sink mark lah. Bottom here, there's a sink mark. Will the sink mark be able to see from the top? Maybe. There's slightly here. What else? Gate filling contribution, there's nothing. Ease of fill. And then you can see weld lines. These are the weld lines of the two material joining with each other. Any air traps. These are the critical area for us to remove the air traps lah. So this is the first result, which is flow. I can see my biggest problem over here is the sink mark lah. I need to do something about this. This one need to be cut out all the way to the bottom. And then maybe I need to rerun again. However, let's take a look at what else here. Fill time, cooling time. Cooling time is there, and then pack. Under pack, I can see pressure at end of packing. So the location which is the first to enter is very packed over here lah. This is the location of the gate. Central temperature, end of packing, average temperature, end of packing. If you don't understand anything here, just go to the advisor. Click advisor. They will explain a little bit on what we are looking at. Pressure, end of packing. What is the importance of it? The pressure exerted on the cavity during the packing stage is controlled by the reciprocating screw. Okay. Average temperature, bulk temperature, and end of packing. And then shear stress, volumetric shrinkage, end of packing. This is the shrinkage lah due to the shrink mark. Seems like I can see some visible line here. See? Some visible line, volumetric shrinkage due to my rib lah. Center temperature, average temperature, frozen layer fraction, residual stress post filling. These are the residual stress. Finally, let's go to warp. So under warping, there's total stress displacement. Berapa mm? Can I animate any of this? Animation? Cannot see? You can slowly see a little bit lah. The shrinkage once it has been cooled down. You can really see how much. Around 0.2 mm change lah in the dimension. And then what else? In-mole residual stress displacement. Quenching thermal stress, sink mark profile. Yeah, this is the best Sink mark profile under warping punya result, you can really see there's a clear distinction there lah. Sink mark profile. So obviously, if we are not careful with the design, you're gonna see things like this lah. They're gonna see a mark. That's why sometimes people put texture to remove the mark. So in my case, if I am satisfied with my design, I should go ahead and do my engineering drawing lah. But then I can see that I have some problem over here. So I should document first lah my findings for the first results. So I need to go to video recording and generate report. Under here, I will click everything lah. Everything will be generated to be saved. Click OK. And then, yeah, this one you can put a title lah. Design 1. Put your name. Anything you want to do. Things that you want to study. Polymer viscosity, results, flow, underflow. What do you want to study? Wet lines, air traps, sink marks, pack, warping. What is important? Under warping, you need to have this total displacement. You got there already. You want this lah, sink mark profile. This is important, right? And then you can click OK. It will help you generate a report and save that report lah. That will be the first thing that we do. Obviously, we need to change our design, make it better before we lock our design and do our engineering drawing. Just let it do the report first. So this is the report done by Microsoft Word. Are we done? Okay, we're almost done. Oh, takes a while. Too many results selected kah? Conclusion. Okay, we're okay. Do you want to save it to another folder? I can click yes lah. Save it to my desktop. Where is it? Default report. You can see some animation files also being saved for you. So there are basically two things lah. You can go for the default report, which has been created. 24 pages too long Don't copy everything and put in your report lah. Just copy the important one only. Let's go through a little bit. Clamping force, 6 ton of clamping force required for this single part. not the whole cavity, multiple cavity. All the results that we need, and everything that's been saved. I like to look at this one lah. This one, maximum pressure, inlet flow, clamping force. Okay, so that one. And there's another HTML format also. HTML format that you can go through. Under here, everything is also recorded properly. Cool result, warping result. Maximum displacement is about 0.2 mm. You can read model, material, process condition, and then result of flow, inlet flow rate. This is much easier to go through. Flow, pack, cool, warping. I like to look at the time, so the cycle time. Where is it? Maybe I didn't select. We try to look. There should be a cycle time. The whole thing goes inside there. Okay, so obviously, if I were to do this properly, I need to go back and redo my design lah at areas which is not suitable lah. For example, this area here, I need to sketch. How do I turn this analysis off? SolidWorks plastics, cavity visibility, turn off. Oh, even the marks are all there. Never mind lah, it will refresh. Let's go back to my feature. I need to make this whole deeper. If I section view, this is where I am having problem lah. This is where I'm having problem. I have a thick chunk of material at this particular location. This thick chunk of material, this one. I don't want this to happen lah. I need to cut off a little bit. If I go to my assembly view, rebuild section from this side, so I can really see my problem lah. I have a big chunk of material here that I need to remove. If you have done that, no need to do anything lah. So let's go back to our this one. Features. Turn off this one. I couldn't see it. Exit. Cut changes. Okay, got it. Right click here, click sketch, Control 8. I need to cut deeper lah. How to cut deeper? This thing has draft already. Draft already. Never mind lah. Convert entities. Click this one. 1. And this one. 2. And then click OK. Exit sketch. Extruded cut. It has to be deeper lah. Control 8 lah. Is it deep enough? Maybe 33. Is 33 deep enough? Let's section it. Currently it's like this lah, 33. Maybe it's deep enough. So if you look at your report, under sync marks, where was it? Under warping, you can see, I cannot see here lah. Actually, there's a sync mark at this D cut location lah. So the best, correct way to do it is that you should roll back before the rib. Roll back before the rib. This one also you need to cut. Or should I roll back before the draft? Huh? Yeah, I should roll back before the draft. Does this thing has draft now? This boss? Did I do this one with the draft? Yeah, got draft already there. This boss extrusion, by right, it should go here. Nah, up until here enough lah. So those who can do, you can do lah. I need to sketch here. And then I need to maybe do a line like so, 90 degrees. And then control this dimension lah. These two here. Oh, not 16 lah. This one. This line to this line. Should be around 2 mm also. Maybe smaller a bit. 1.8. Maybe 1.5. Click OK. Exit sketch. Oh no, this sketch is not enough yet. Complete the line. Exit sketch. And then extruded cut. Click the sketch. Extruded cut. Blind up to next. And then click OK. Open contour. Do I have an open contour? Okay, I gotta repair my sketch. Control 8. Trim entities. Where is my open contour? Cut off everything lah. Exit sketch. Extruded cut. Click the sketch. Extruded cut. Up to next. Can kah? Up to surface lah. Up to surface. This surface. Click OK. Yeah, like that. So this one will make the material thinner. Now if I roll back to everything, my design will become like that lah. So this one has removed every single area which is not uniform thickness. You can check here, right? Evaluate thickness analysis and then calculate. This will tell you which are the area which has very thick section that we want to avoid. Thickness scale. How to understand this scale? Greater than 3, 1.5. The green color, discrete, change to discrete. Easier to see kah? So orange color is okay lah, 1.6. The thick one is you don't want, the green color one you don't want. Full color range. Continuous. Okay, so this is the way for you to do lah. So if this is okay, you are satisfied with the design, obviously you can run flow again, flow analysis again lah. But you don't have to. You should lah. If you're working, you should lah. Save all first. So the next thing that we want to do is we want to do multiple cavities lah. So save everything, save all, rebuild the documents. one entity's made is suppressed. Oh, this one is under my assembly because I changed many things here. My assembly might be in trouble a little bit and to repair. Yeah, certain features are gone. So parallel mate is gone. You need to repair lah, whatever that is wrong. This is probably a bit because this thing can rotate already. If I were to change this one, I cannot see inside lah. See inside like this. Where is my D-cut shaft? Still cannot see section view also can. More confused Okay. Repair it lah. Repair the disco incident lah. Suppress first. Now I can move this one up like that. Then I can understand lah. You need to meet this face to this face. Click OK. And then you can unsuppress this one. Now everything is good lah. I can section properly now. Flip. Okay, like so lah. Alright. So once you've done that, go to your knob. Make sure this thing has been saved properly. Save all. So next thing we want to do is we want to do multiple cavities lah. If you look at our project here, we want to start with doing this one lah, SolidWorks plastics. There are a few parts. Just now we did all three, right? Up until warp. Standard fill is these features that you can do. Fill and pack, you can even check this one. Cooling time, this one is important. And then for warping, this one will bring back to the room temperature and see the difference in sizes. So we want to do this one, which is 4 cavity. After we have done this one, we're going to do 6 cavity. And then we're going to do 8 cavity lah. So the main thing that we need to go here is that if you have 4 cavity, the runners will be equal length. So the filling will be okay. But if you have 6 cavity, if you do it like this, it is not good lah. But we purposely want to do this. We want to show that if you are designing your runner like this, the center knobs will be filled in first. The knobs which is further away from the sprue will be filled in last. So if you do analysis, warping and everything, the center knobs will have different dimension lah compared to the rest of the cavity. So this is an example of the thing that you don't want to do. So, but we are running it for the purpose of study lah. You want to do like this lah. This is the best way to design your runner. So you can use a H system. H runner system. Look for it in the Google. And what they do is they starts from here and then goes here and then turns left, turns right, and then this turn and this turn. Every single thing will have the same distance lah. Every single part, every single cavity will have the same distance of the runner, so it will fill up at the same time. So I'm gonna do an example of 4 runners first. You can design however you want to design lah. Let's go back here. In order to do the runners, you need to go to File, Make Assembly from Part, and then put the knob. So this is the first knob. Notice I have turned off my engraving to make my job easier. Afterwards, I can go to linear components, linear component pattern. Direction would be front plane car. And then direction 2 would be right plane. Component to pattern would be this part. I'll put some distance to it lah. 120, 120. Maybe like this. So if you notice, it should mirror lah. It should mirror actually, if you really want to do it properly lah, because of the D-cut. If you are very good and very strong, you can mirror lah, because you want the thing to go into the D-cut. I suppose it won't be a problem lah, but you should lah, mirror. So this one should be 1 only. Click OK. And then we can mirror the whole thing. How to do mirror? Mirror components. Mirror plane would be our front plane car. Right plane? Right plane is there. You cannot try lah. Mirror component. What is this? Wrong already. Delete. Don't make your job too hard lah. Just change this one lah. But right, you should do mirror lah. Change this one to 2, easy lah. Okay. But I think the industry, they will mirror this one because of this D-cut. They want to make it really, really good lah. Okay, so let's go ahead and in order to do the plastics analysis, you need to go to assembly, pattern these components, and then save file, save as. Don't save as assembly. You need to change this one. Save this one as part. Only then it will work. Because you cannot run assembly using plastic analysis lah. So you can name this one for cavity. Or T pula dah. For dash cavity. Save. Okay, we're done. Where are we now? Is it in the assembly? Yeah, still assembly, eh? So now I can change this one lah. Change this one to 6 cavity. Make my job easy lah. Save. And then file, save as. Where was it just now? Change this one to part. Make sure you have 4 cavity there. Click this one. No, don't replace. Change the name. 6 cavity. Save. 8 cavity is a little weird actually. Because of the runner system, maybe you want to adjust certain things. You can check it out lah. And then 8 cavity. Yeah, like so. And then save as. Make sure it is part. And then you click cavity. Don't replace it. No, just change the naming lah to 8 cavity. Save. Okay, so once you've done that, you're gonna see 8 cavity, 6 cavity, 4 cavity. Open up the file. Make sure it is in part mode. So this is part mode, not assembly mode. Okay, 4 cavity, not assembly. Make sure it is part mode. Only once you do part mode, you can do analysis lah. So you can jump over back to SolidWorks Plastics. Drag this thing. Go to this icon and then go to Shell, Manual. Next, do the similar thing lah. And for this one, you cannot mesh it to be too fine lah. So it will detect all 4 cavity. Make sure it is cavity, not cooling channel. Click next. If you try to do 1.5, right? Let's say I put 1.5. It's going to create for you 88,000 elements. What is this? 170,000 nodes code. Tetrahedrons. Tetrahedrons is the element. Let's say if I click mesh. Just for the purpose of checking, I will create 84,000 elements. There you go. So element 84,000, which is maybe too heavy for our computer lah. So for the purpose of this study, you should increase it lah. So 1.5 kena kali 4 lah. So jadi 6. Kalau nak maintain same computational punya power lah kan. It becomes like this lah. It's not so fine. It won't be so accurate. So it won't be so accurate as the first analysis that we did lah. But because of computational power lah. Maybe change to 4. Mesh again. An element size that you are comfortable with lah. 130,000. That's still a lot lah. Mesh. Maybe too much lah. Go to 5 mm. Mesh. Why so small? Like 10,000 only. That is too small code. Maybe 4. Click mesh. 13,000. 2.5 Mesh. 13,000, not 130. This one 30,000. 30,000 okay lah. Okay. I'm settling at 2.5. And I'm going to click next. And I'm going to click OK and then click OK again lah. So it's better to maintain a similar mesh size in order to make our analysis comparable lah to each other. 30,000 element, okay lah. So next thing we want to do is, everything has been settled, right? The material is already ABS. Injection location, this one you need to do the runner first lah. So go to our flow injection location, no. Go to channel design. So go to channel design, click design. So don't go for cooling channel, click runner. So runner, in order to do the runner, you need to sketch. So you cannot go here yet lah. We have to go back to our parts. Okay, we need to sketch the runner lah. Go back to features. Why is it like this? Click this one. Okay, let's create the runner. So the runner need to be designed on this face lah, this surface. Right? So go to this level surface and then click sketch. Control 8. Let's design the runner. Click line. Highlight here, center, and then can you go here? And then hover and it doesn't detect. It doesn't detect. Will it detect this one? Make sure it is touching. So if you go like this, you gotta convert entities, hujung sini, click OK, and you gotta trim it. Trim here, trim here. Oh, everything is gone. Okay, let's do it again. Let's go to this one lah, easy. This one to this one. Okay, one runner done. Go to center. This one access tak apa. This one can you, yeah, you can snap. You should do runner. Actually, everything should be one piece to one piece. Not like this. This is two piece, right? Two piece connected. No. This one you have to trim and then make it one piece to one piece. You'll see the reason why lah later on. Make sure it is touching, otherwise the material cannot flow in. This one you need to trim and then do another runner here. And then this one you need to select the middle. Where is the middle? And then you need to trim it. Trim this one. Trim this one off. And then trim this one off. And then connect them together. So all together you see one line, two line disconnected, three line disconnected, 4, 5, 6. There are 6 lines which has been disconnected. You can exit sketch. So that is how the runner look like. Finally, you need to do another 3D sketch lah. Go to sketch, click here, click 3D sketch. Go to line, go to the center here. And then you want to do the sprue. The sprue is probably that length. Too long kah? Shorten it a bit. So that is the sprue lah. So every single line must be disconnected. Not disconnected, connected, but their own section lah. So now I can exit. Now I can jump over back to my plastics lah. Go to plastic bag, go to channel design, click design. Make sure it is a runner. So there will be two things that you need to set lah. D1 and D2. I think D1 is the entry, D2 is the outer lah. Entry is smaller on the sprue entryway lah. Maybe you can put 5 code. 5. Select this one. And then click assign. So we'll do the thing lah. And then this one change back to 10. Click this one. Assign. Click this one. Assign. And then you need to change this one back to 5. This one. Assign. No, wrong. This one. Flip dimension. And then click this one. Assign. Flip dimension. Click this one. Assign. Another time. Flip dimension. Click this one. Assign. This one is okay. So once you've done that, make sure it is runner, not cooling channel. Click OK. So the runner has been completed lah. So once we've done the runner must be connected to your part. We can assign the injection location. Obviously at the top here lah. At the top of the sprue entryway. And then click add location and then click OK. If your computer is very powerful, you can run up until flow, pack and warp. But since we are having like 4 cavities, so many elements, I'm just going to run flow only lah. Right click flow and then click run. Okay, so running now at 40%, 50%. $60 now. All right, so we have finally done it. So this is the fill time for cavity lah. If I were to run the animation, it will fill the whole cavity. So you can do the same procedure for all 6 cavity and later on for 8 cavities lah. So you have to design your own runner system. I think you can Google up H runner design. H runner design plastic. Don't see anything. Oh, this one. Runner sizing. How you do design the runner lah. You break it apart into H type. You have the main runner and then the second level runner and then the third level runner and then fourth level runner lah, if it's available lah. Some sort of like this. So you can go over and look at the thing that we have been going through lah for everything lah. Do I have improvement in sync marks? Most likely. See, I don't have any error. No, not error lah. Some warning on sync mark anymore because I've changed my design. Okay, so that's all for the analysis for 4 cavity. So you need to proceed and do for 6 and 8 lah. If you have a very super computer, you can run flow, pack and warp lah. But if you have normal computer, just run flow analysis is enough lah. Alright, thank you.